morning for being here. We'll welcome you once again to today's sessions, Blockchain 101 for Developers, as the title implies. This Blockchain 101 is not your normal Blockchain 101. If you have attended any Blockchain 101, the fundamental of blockchain. This one, I put in more information in, especially it is for the developer to understand before they start developing any smart contract. So this is mainly made for the participants of this algorithm-rich smart contract program to the participating university. And I am the person who going to deliver this training. I'm Ivy Fong. I have met some of you, and a lot of you we met first time here today. Welcome. Now today, a little bit about me, just a little bit about me, so that you know why I am here to speak to you, right? Before the blockchain started, I started as a programmer. Then I stopped and moved on to other industry and in the management and marketing and sales area. Then when the blockchain comes, I kind of intrigued by it, and I think that it's time for me to come back to the IT field. So during that time, I started as just like most of the people joining the mining pool, doing trading, but I really get interested by this blockchain technology. So when NAM, one of the blockchain company that opening an office in KL, I applied and I have been working there for the past 3 years. During the time there, I was focusing in creating syllabus for university, and I spent half of my year in 2019 in Philippines training the lecturers in the university in Manila. And other than that, I do training for system integrator developers as well. So most of the time when I was in blockchain is doing training. And if you would like to know some of my other sharing, this is a QR code that you can scan to go to my Linktree, or you just go Linktree/IvyFong. Then you can get to my social media where I share some of the information as well. Now, enough about me, and just want to talk about today. Now, today is not your normal class like you go to school, you have a semester to learn about what is blockchain and practice along the way. This is a crash course for you before you start your course on the 5th of September about the smart contract. Now, blockchain technology change very fast. It doesn't mean that after today you know everything about blockchain. There will be a lot of improvement going on, and if you really want to stay on with this blockchain and you really see the future, you have to keep in touch with what's happening in the market. So, and as we go along, like I mentioned just now, ask questions at any time. Put it into the Q&A. I'll pick it up. I'll just keep my eye on it. And if I forgot to look at the Q&A, just put it on the chat as well. I'll just pick it up from there, or just say that Ivy, please look at the Q&A. And the reason that I do not want to say wait for me to finish this session that only you ask questions is because there might be some questions that I need to understand before I go on to the next point. And most importantly, participate as well. If I ask for feedback questions that would help me to understand that what other things that you might need to I might need to explain more. Your learning doesn't stop here, and be open-minded and be creative, especially later on during your hackathon. Be creative with your topic for your hackathon. Okay, come to the agenda. What are you going to learn today? First part, learn about what is blockchain, the composition, the mechanism, how it works, and the architecture. Second part, we learn about the problem the blockchain solves, to understand a bit about what is the basic of smart contract, the crypto asset, and then later on we talk about the challenges. Blockchain is not without challenges. And fourth part, we talk about the tools and some of the use cases. Okay, your participation come in now. Can you put in the chat? It's the chat, not the Q&A, the chat. What do you think is a blockchain? When we talk about blockchain, what comes into your mind? Can you just type in the chat box? Let me see. Decentralized, yes. Come on. Keep the answer coming. Participate. Huge secure database. Nice. Unrepeated. Dogecoin. A chain of block of data. Crypto. Data blocks crypto. Link with one another. Now, so later on, after we go through these sessions, relate back what you say. Does it really have been mentioned? Immutable ledger. Okay, more. Give me a few more at least. Transparent, yes, nice. Yes, any more coming? So when we talk about blockchain, right, these are the few words that we always hear about. It's a distributed network, it's decentralized, it's transparent, it's anonymous, immutable, secure, fast, economic, and just another database. Somebody mentioned about database just now. Is it just another database? Now we are going to look at this one by one. So what exactly is blockchain? So it's actually quite intuitive, it's literally means blocks that are chained together, but you chain together with cryptography. Anonymous identity is yes and no actually though. First, if you would like to participate in this blockchain, it means that you want to send transactions, you want to keep your data there, you want to do the transfer of cryptocurrency or NFT. What do you need? People will say that, like, first set up your wallet. What actually is a wallet? Do you need a wallet? In the matter of fact, you actually need an account, and this account is a keypad. So I think this might not be something new to you, which is the keypad, the private key and public key that is used in cryptography for authentications, as well as in blockchain. Here you can use it like your account or the address that we're talking about for your wallet. So you have the private key, and the private key is something look like this. And the private key, as the name implies, don't ever share it with anybody, because if you share the private key, you lost anything in your account or in the blockchain. And it means like the account on the blockchain. And then from the private key, you'll derive this public key. And the public key, as the name implies, is meant for you to share with somebody so that they can send anything to you. And this is an address. All these are just an example, okay? This is the address of generally for Ethereum. You look at the 0x here. Now, an address is kind of like a shorter version of the public key, but with more information. For example, the 0x in front tells you that it's an Ethereum address. So generally, this is the two things that you can share out, and this one, no. And this is used in the asymmetric cryptography as well, when you want to send decrypted message over to the other person. Where using the private key and public key, you can encrypt the message you want to send to the other party using your private key and the other party public key, and the other person who accept after receive your message can decrypt it with the private key, and then together with her or his own private key. Okay, now if any way that I go too fast and anything is not clear, I have to emphasize it again, put it into the chat and I will repeat it. Now some of the times, right, you might think that, like, okay, I already know this. Just be aware that, like, just now when we do the poll, most people say that like no, they have zero knowledge or a little bit knowledge about blockchain. So I will just go into quite basic. Now we're talking about ledger just now. Just now somebody also mentioned about the distributed ledger. So what actually is the ledger and how this ledger, which actually is the what we call the block, being linked together. Now, if any of you here do have a bit of accounting background, we do know that like for accounting, right, we have a brought forward balance, which is the opening balance of the month, and then we record all the transactions. Then we have the closing balance, which is the balance to carry forward to the next month. And then for the next month, it starts the same again. Now, the ledger in blockchain works is the same way. Now, when you have all the transactions being collected, you put it in the ledger and you hash it all the informations, including the number of the block, the nonce, and the transactions happen in together with this previous hash. We'll hash it and get this and brought forward to the next block. And this is how it's being connected. And if you think back to, you relate back to the account, right? It's the same. Because the closing balance you get that brought forward to the next month will include all the transactions and affected by the opening balance, which is here, the previous hash. And probably what is not including into the balance is, but the informations available is like, you know, what month is the ledger belong to, in what year and such. But here is the height, the block height number, which block of it. And here there is something called the nonce. No problem. We're going to talk about it later. So this is actually how the block is being chained together by the hash. Now, if any single thing change, even just a little bit, either in the transactions or in the nonce, this hash will look totally different. And when it's changed, if somebody come and hack this, and it caused this hash to change, it means it will not be able to link it to the next block anymore, and it breaks the chain. When the chain is break, when the chain is broken, anybody else in the network would know. Now, if in any way what I say now you do not get it yet, no worry, because this will somewhere somehow being explained in the later. Now, remember just now I talked about in the ledger here, if we take this and enlarge it and look at it, it's look like this. So in a block, it will have the block height, that's what we call HEIGHT, the number of the block. So for every single block that added to it, you plus 1. The reference of the block 6, which is the previous block hash, and the transactions that happened during this period of time. A nonce. Now, a nonce is a number that is going to use once. I think this is something that is not new to you, or especially if you have coding experience, which this number will not be repeated to in the future, or it never happened, it never being used previously as well. And the timestamp. Now, with all these informations, it form a block, hash it, and that's the link. This is also what is the timestamp server is all about. As since all the hash over here, now if you don't really get the idea of the Merkle tree yet, no worry, just want to let you know how this works. Now, this hash, as we mentioned just now, it involves whatever happened now, the nonce, and any other informations that is not shown here, but it will be included into the block together with the hash coming from the previous block. That means that this hash here, the newest hash, would have include all the informations from the previous blocks. So if you look at here, if this hash is here, it means that like it belongs to the previous block, and then it also belongs to the previous and the previous until the first one. Now this is the Merkle tree. Don't confuse it with a blockchain, because a blockchain is only one chain. It will not have so many, and this is just showing you how the Merkle tree works. Now, why is it important? Some blockchain use variations of the Merkle tree, but generally, because of this technique that you have it here, if you want to prove if this block with this hash belong to the original, the main chain, all you need to do is just take the previous hash and hash it with this to verify if the hash given to you is the correct one. Then you would know whether this block actually belong to the chain. Now think of the idea of if you guys have worked of like how the password works for the website is they don't actually keep your password. It's more like when you key in the password, they will run through the algorithm and see if matches whatever the outcome or the digest of it. If it's yes, that means that you actually own the right password and you get access to the website. So this is kind of like a similar idea how you prove that this block is actually belong to the right chain. Now that's all you need to know until this stage. Now, if you look at Bitcoin white paper, you will see this name there. The person where Satoshi Nakamoto referred to, the timestamp, that is the theory by these two persons, Haber and Stonetta. They actually made the blockchain an analog blockchain even before Bitcoin. How that is they have the information, they have some information that they are collecting, they hash it, and they publish the hash on the newspaper. And they have been doing that for since 1995. Now this is like what I said, an analog blockchain is because this is not really on the internet, but it still used kind of the hashing technique, and it still published and is very decentralized. Says you put it in the newspaper, and the newspaper is distributed to so many people around the country. If you go back and change some of the information on your copy of the newspaper, you are not going to fool anybody, because just anybody have keep the copy and come and show you. Most people have the same that is different from yours, then your information is not considered the true one. So this is a good example of how distributed network make blockchain secure. We are going to talk more about it later. Now, one of the things we talked about just now is people always talk about blockchain is because of distributed network. I believe you all know very well what is centralized network, what is decentralized, and what is distributed network. And as we mentioned just now, the newspaper, when it's like published, the information is become transparent, right? And in blockchain, it's the same thing. When you publish all the informations to everybody, it becomes transparent. That means it's transparent, right? Whenever you publish, it's transparent to anybody to look at it. And the best way to keep a secret is always to have no secret. When you have everybody know about something, it's very difficult for any one of the party to dispute against it, to say that like, oh, it's not this way, because the rest of the people will say against you. Now that is then we come to this consensus protocol. Now the consensus protocol is also a very important part of this blockchain. Is because now we talk about blockchain is in a network, and just now as we talk about this, it means that like the information is not only stored here. Like when in centralized network, right, the database, the server is the god, right? Whatever information is there is right, because that is the only source of truth. Now here in more decentralized one, you have more copy, but in this case, right, even if the hacker want to go and change some of the informations, it will still able to do that, because it's not that difficult. Of course, security is getting more and better and better, but sometimes the hacking skill is getting better and better as well. And when it comes to distributed network, it means everybody, there's no client, there's no server, everybody keep the same copy of data. And that make the data transparent, because you have a copy, you'll be able to get access to the data. Of course, some sensitive data you can encrypt it. Now, when everybody, right, in the network, there is no server, there's no one database administrator, it would be a bit difficult, right, to come to a consensus, right? You do not know that, like, which that we need to listen to. So one of the main thing for this blockchain technology is to have this consensus mechanism. When there is all the nodes in the network states, you have 100 of them. As long as that is more than half of them saying that, okay, we agree with these transactions, we agree this block is going to be accepted into this blockchain, it is what we are going to accept. Now, why it is so, I'm going to explain more when we come later. We talk about how the blockchain works. But generally here, the consensus mechanism is using this kind of mechanism to get a consensus whether we want to act on a certain things. Proof of work, as we understand, is using a lot of computing power, where all the nodes in the network need to guess equations. Now, think of it almost like 2 plus 2 is equals to 4. But that is easy questions. But if I say 4 is the answer, you need to give me the equation. There could be hundred of thousand of answer. All they can do is just guess the equations. And this is why that the higher power the computer have or the machine have, you'll be able to guess more time and your chances to win is higher. Of course, whatever you're supposed to guess is so much more complicated than just the answer is 4, guess the equations. Now, when it's come to proof of stake, it doesn't use the computing power, because the computing power is basically taking up quite a lot of energy. So it comes up to be this a proof of stake. As the name implies, proof of stake is more like you have this much of coins that is the native coins of this blockchain. The native coins means that is the coins that generated when this blockchain started. Then you stake it there. With this, it buys you the chances to include the block in the blockchain. Now, how it works, we're going to talk more about it later. So generally at this stage, all you need to understand is proof of work. You need to guess uh, a riddle, the equations or whatever that is like used by that blockchain. And proof of stake generally is based on how much of the stake, the native coin you can, and you put it there and say that like how this is my deposit here. With this deposits, you give me the chance to include the block. And based on the amount of your stake, it almost like a raffle or a lucky draw. The more stake you have, you more ticket. With the more tickets, you have more chance to take to be the winning one. There is a lot more variations coming out of this proof of stake. You will hear like delegated proof of stake, pure proof of stake, and generally the idea won't run too far away from this. It also does have an incentive system for this blockchain as well. You don't really hear much people talking about it when people are talking about what is blockchain. You only hear about this more when people are talking about mining, and that's where the incentive come in. Just now we talk about uh, blockchain is in a distributed network where everybody or every node in the network will have a copy of the data. But why people want to do that, huh? And why people want to do the to run the nodes and go through the process of the mining, which is the proof of work. You spend so much of energy. You need a specific machine. People do that, of course, there is an incentive system. Like for Bitcoin, when you do the mining, which you run the whole the process of the proof of work, you will get the transactions fee that people pay when they transfer the Bitcoin, as well as the new Bitcoin minted during that block. So if your nodes, your mining nodes, is the nodes that form the block, you'll be incentivized. So if you same goes to proof of work. If your nodes are the one being selected to include the block into the blockchain, you will be incentivized. Now, some of the blockchain might only have incentivize the nodes with the transactions fee. Most of them do have this uh, new coin being minted as well at the same time. So when you send any transactions, when you want to transfer any Bitcoin or any other coin, there'll be a transactions fee, right? Now, those transactions fee, it's just like you going to the bank. The bank is going to charge you administrations fee for your transactions. Like usually it's only for the overseas transactions as nowadays. Those transactions fee is going to reward those mining nodes. And then at the same time, new coin is going to be minted. Now, the new coin being minted is already in the algorithm when the blockchain network started, when they are being built. As it start from the first block, it will start following whatever is in the algorithm. So that is where the rewards come from. Yes, Omar, minting a coin is creating a new coin. That's the words that, no, this is some of the jargons. If some of the jargons I mentioned is not really, is not being explained well, or please mention it in the chat as well. Minting a coin, it's just like, when if you go to the Bank Negara, they will say that, like, they also call it the minted coin, the actual coin that we have. It just because money, the coin is also called a mint, and we creating the coin, so it's also minting the coin. Even NFT, we call it mint and NFT as well because it's the token. So yes, that's creating the new coin. So Nurhaliza, I hope I answered your questions regarding where the incentives are coming from. So we're talking about security in the blockchain. Is really secure, and why the blockchain is what make the blockchain secure? Well, just now we have talked a lot about having using the private key and the public key, the key pair system. We talk about all the informations is being distributed to everybody in the network. We also talked about when your information is being distributed to everybody in the network, it means that it's transparent. And for public blockchain, not only when you are one of the nodes in the network that you get the information. Even though you are not using the blockchain itself, you will still get to see all the transactions. Again, we'll talk about it later. And consensus protocol. And all these things, right, make the transactions or the data in the blockchain immutable. It means that it cannot be changed. Why is not able to be changed? Because whatever informations in the block that include your transactions, that means all the informations that is on the blockchain is there. Once the block is formed, it distributes to everybody in the network, and that way everybody would know the informations. And because it's transparent in that sense, and it's all the transactions need to be signed with your private key, it can't be changed. So if one person or one malicious actor want to come in and hack and change the data, it's difficult because it has to change 51% or more than 50% of the copy in the network. If the network have only 5 nodes, that's pretty easy for the hacker to go and edit the information in 3 nodes. But if the network is hundreds, thousand, it will be very difficult for the hacker to do that, because we also have this consensus protocol where in a period of time a new block is going to create. Remember just now when we talked about the hash function, whatever hash functions of the previous block is going to brought forward to the next one. Now, if within this period of time before the new block is formed, the hacker is not able to change all the data in more than half of the nodes, he has to start all over again, because whatever it is he able to hack will not be relevant anymore once the new block comes in, because it's not going to be linked anymore. Remember that anything changed in the previous block will affect the hash. Yeah. Up until here, is it all clear? Is there any questions? Let me just check. I don't see any Q&A. I don't see any questions coming from the chat. So I believe everybody is good. Okay. Now, fast and economic. A lot of people will say that blockchain make the transfer of the money very fast and cheap. Is that so? Now, is it faster? Is it cheaper? The ER there is superlative. It means that as to what you're comparing to. We are talking about creating a block. And when we create the block, for the block to form, it takes time. Each block, different blockchain, would have a different duration to form a block. Bitcoin, average about 10 minutes you form a block. For Ethereum, roughly about 15 seconds you form a block. So, remember also, just now that I mentioned, if a hacker would like to come and hack the system, it needs to do it before the next block is added to the blockchain. Before anything happens, as well, whatever transaction that you send, there is a slim possibility that it might not be included into the block. So when you have sent a transaction, you need to wait a certain period of time in order to make sure your transactions is included into the block. That means that it is valid. Now it's just like when you do any bank transfer or anything, whether there could be any issue that when you just send something's wrong, it missing interaction, it doesn't go through. For example, as you send, and you can see for example, using a credit card, you can see that it keep on loading and loading. Matter of fact, the internet connections might not be good for it to go through. This kind of idea. So in order for you to make sure that transaction is being accepted, you need to wait for a certain period of time. Usually they will say that 6 block after your transaction is being included, and that could be come up to be an hour. Now imagine if I want to go and buy an ice cream in 7-Eleven, and I say I want to pay with Bitcoin, says if they accept Bitcoin. And the people behind me have to wait for 10 minutes for my, or an hour for my transactions to be really confirmed. How long the line is going to be, right? But if says that I want to do overseas transfer, and usually take about a week to clear and everything, using Bitcoin is so much faster, right? And using Bitcoin, the fee could be cheaper as well. But if I just pay cash to buy my ice cream over the counter, I don't have to pay any transactions fee. But using Bitcoin, I have to. So whether it's faster or economic or cheaper, it really depends on what use case that you have. How's the coin getting the value compared to the normal money? Okay, Narendran, this is not some topic that we are going to talk about today. Today is going to be mainly for developers. We are focusing on the mechanism of it. Yeah, maybe a bit more technical, but I will quickly answer the question. It's just like any of the money out in the market. They are not backed by any commodity. They're not even backed by gold anymore. So the value of it is totally depends on the supply and demand. If people want to use it, there is a value. If there is not, then it can just plummet at any time. So nobody determines the price of the value. The use, if you really want to know, want to say that there must be somebody determine the price. That would be the user. Everybody, you and me. If you is a willing buyer, willing seller. Alright, from Amatilla, reality, use case behind the coin, and much more. I think it's just your sharing. Alright, from Osama, what if a user claims that he has a higher amount than he has and try to send it? How blockchain prevent this kinds of actions? Now, Osama, you might get better idea as I go along as well, because we are just talking about the general concept of blockchain here. But remember that we talk about all the transactions will be recorded into the blockchain. So now I will answer it here a bit. In blockchain, generally there are two ways of recording how much of balance of coin or assets you have in your wallet. One is called the UTXO, which is the unspent transactions output. This I'm not going to talk about today, so that's why I answer your questions here first. Is just you have $10 in your pocket, right? And you want to go and buy an ice cream, and the ice cream, right, costs you 1 ringgit. So what you're going to do is you pass over the 10 ringgit in your hand to the cashier, and the cashier is going to return you 9 ringgit. And the 9 ringgit is the unspent transaction output. And that is the system the Bitcoin use. So your unspent transaction output, right, will be in a pool tied to your address. And every time when you want to do send a transactions, before your transactions become valid and accepted by the blockchain, they will go back and count this pool and see whether you have the balance. If you don't have the balance, your transaction is not going to be valid, it's not going to be accepted by the blockchain. There's no overdraft in blockchain. And for the other system, which is used by Ethereum and most of the others, is the like an account balance system. It's like the bank account you have now, you have a debit card. So the bank will keep the balance of your account, how much you have inside. You put money in, then the amount will be more. You spend it using your debit card, then you're minus. So when you swap, if you do not have the balance, then you cannot spend. Osama, I hope I answered your questions. That is what you want to know. And how exactly you keep that into database, you only need to know this if you are going to be a blockchain developer, not even a smart contract developer. Only if you are a blockchain developer and you look into how the database is done. And probably that is the Merkle tree that I mentioned earlier on. Okay, thank you. Got it. I see another questions. Let me just check on the questions. Nuhaliza, why there is a transactions fee although there is no third party involved like the network? Now, good questions. We keep on saying that like blockchain is to get rid of the third party that charge you the middleman fee, like the bank and such. And why we still want to pay the transactions fee? Now, even though there is like no third party involved, the third party there is basically because we do not, like two parties, right, that is dealing with each other might not trust each other. This is the reason why we need a third party to mitigate. When we take away this third party, are we really trusting each other? We might still not. So we put the trust now into the code. But even though you run the code, right, somebody, and the code is deterministic, right? Whatever you tell is already inside the algorithm, it will follow exactly what you tell it to do. But then somebody still have to run the nodes, right? And all these things, if without people running it, the network is not there. But why the people want to do that is because there is this incentive, just like we mentioned earlier on. If without this incentive, who want to run it? So that is why that like we need a transactions fee for the network to go on. I hope I answered questions. Okay, let's continue. I don't see any question anymore. Let's continue. So, is blockchain just another database? Yes and no, actually. Now, in a database, right, you generally would have this like you can post new transaction. You can query the transactions, of course, and you can edit the transaction, the data put inside, and you can delete the data. And if you forgot your password, you can ask the database, the administrator to go and change or reset your password. And all your data is stored there. And for blockchain, yeah, all the transactions and all the data, whatever happens, is going to store there, but you won't be able to delete it. You won't be able to update it. The only thing you can do is send a new transactions to correct whatever before it if you get it wrong. Now, this is very similar to how the accounting system works as well. By the good accounting practice says in the month of January, you record a transaction, says Ivy sent 100 ringgit to A. Actually, and then in August you realize that actually I sent 1,000, not 100. You do not go back on January to change the amount. You are only going to add in this month another 900 that I sent to A. Probably do some remarks there. Why you do not do that? Because when you do that, right, that means all the closing balance of that month, right, have to change, and the opening balance of the previous months have to change, and it affect every other month's continue, and that breaks the link if you do not edit every single month of it. Of course, you can do that. You're not able to do that for accounting system, yes, but that would affect everything. Then for blockchain, you won't be able to do that, because remember we're talking about the hacking and all these things, and the hashing. If you change anything in the previous month, it will change all the hash, it will break the links, and we do not want to have that as well. It's because first, there's new block being created every minute most of the time. To do that is very difficult, and if you able to edit anything, who want to trust the blockchain, right? So the system make it in that way that like you do not able to do that, and that is because of the consensus protocol as well. Now, so it is a database because it's keep all the data that, like, who sent Bitcoin to who, and from here is sent to who. So it tracks the movement of the Bitcoin or any other coin in different blockchain, but you cannot edit it. So that is the difference from the normal database. Now, up until here, probably you have noticed sometimes people will find blockchain a little bit difficult to understand, is because there is a lot of moving parts, and each of this moving part, if you change something here, it will affect the other one, and if you change something here, it affect the other one. No worry, as you go along and you kind of like understand a bit more, and for you all, probably when you start to do the coding part, it'll give you more understanding that, like, the interdependency or the interrelated of this all different parts. Let me just look at the questions. How can relate okay, no. How can we relate the blockchains to a normal database, Narendran? I'm not sure. Okay, can you explain more which part that, like, you don't really get it? So the normal database usually is, okay, look at blockchain more like a log than a database. The blockchain mainly is recording. Now, Ivy sent Bitcoins to 1 Bitcoin to Narendran, and later on Narendran sent half of the Bitcoin to A, and then A later sent a quarter of the Bitcoin to Osama. It keep all this kind of log, and that is the link to who sent it, who is the recipient. So all these kind of things, right, is quite similar to a database, but you cannot go back in history and say that, like, now I would like to change the data. You can have another transactions to kind of like put on top of another layer of the data there, but you cannot totally wipe off whatever have happened. The record of the old record is still going to be there. For example, you want to keep your informations of your address in the on the blockchain. You won't be able to delete whatever the old address you have it there, but you can always have another new address on the blockchain. So that's generally is the difference of the blockchain. I hope I answer your questions, Narendran. Like update a part is not available, so if the user want to update a part, will they consider as another block? Now, Narendran, yes and no, because you do not go back to the same block to edit it, because blockchain is time sensitive. This block is formed, nothing is going to change about it. Like I mentioned just now, if you want to, if you record the address here and you want to update your address, the only thing you can do is like at whichever block you are at that you decide you want to change your address, you do it in that block that is going to be created. And once your transaction is accepted, your new address is going to be accepted and recorded into the new block. Now, remember that, like, that you are being asked to learn React and all this, because there will be a front end that you need to build. So the front end will just going to go and read and say, I'm going to pull out the informations recorded in this blockchain, the latest address of this person. So you just ignore the previous one, you just get the newest one. Right? I hope I can answer your questions, Narendran. Just give me a yes and no. Okay. Okay, cool. All right, so there's a difference between, like, how a blockchain and a database is. So when people hear about, like, oh, you keep all this information, so it's just another database. So that is what I mean by yes and no. Why blockchain suddenly appears in this, like, past decades, or start to get even more popular? Other than, like, the reason because of the fall of the banking system that lead to creations or of this new type of cryptocurrency called the Bitcoin, and then supported by the blockchain technology. When Bitcoin started, that the word blockchain is not being really being used yet. It is only later. Now, actually, the same concept has been in the mind or being researched by the elite, not really available to the public. It's for a few reasons. First, internet. We want to have all these informations, right, being sent, probably across the sea, and everybody get the copy of the information, and they are not only nearby, and they could be like all around the world. Internet is very important, not only about the speed, the availability, as well as the cost. And this last decade, internet is getting more and more available, cheap. So that helps the rise of the blockchain. Secondly, we talk about proof of work, right? The computing power, the ASIC mining machine. ASIC mining machine is a mining machines that focus on the computing power, not the rest of the functions of computer. They focus on the mining. Because of the cost of this hardware is getting cheaper, and the power is getting better, that only then can support the blockchain. Now, when Bitcoin just started, the network is very small, so even you using normal computer, with a good GPU, you can still do it. But as the network grow, it's just not gonna make it. So because of the chip getting the material getting cheaper, the machine getting cheaper, and the function the capacity of the hardware getting better, it helps the rise of the blockchain again, as well as storage. Now, everybody need to store the data since the very beginning of the blockchain started. Of course, it will need a lot of storage, And those were those days when we have a centralized network. Other than because of the internet, storage is also expensive. Now the storage is getting cheaper and cheaper and more affordable, and technology is getting better and better. Like with things, a technology like Merkle Tree and uh, any other way of like compressing the data, it helps also to the rise of the blockchain. All these are going like progressively. So blockchain generally is not a technology that is only about take it more old. It come a long way. It's just that it is now merged into a blockchain. Let me just see the questions. How can relate okay, it's still the same questions. How can relate digital money to blockchain? Okay, I'll just quickly answer these questions as well. Now, cryptocurrency is, or digital money or cryptocurrency is only a functions that is supported by blockchain. Now, Bitcoin, you can say that it's a digital money, and blockchain is the technology behind it that runs the whole thing. It creates that environment for this digital money to be able to exist and function. Okay, the revolutions of the internet. Just now we mentioned that the internet, the blockchains become more popular and start to, get more people to involve is because of the internet as well. And at the very beginning when internet just started, mainly is for the exchange of informations and something like email. And well, come when the web started, then we have the static website, and it's still for the disseminations of informations where I create the website, I show you some informations, you on the other side can only consume the informations. So generally we call that the internet of informations. Then come later on where internet is getting better, and we are coming to this era of internet of things, where the things connected to the internet can talk to each other. We do not even need to have the human involvement to tell them that like what to do. Now I'm not talking about like things like smart city or whatever that you can control the aircon or whatever from your phone or anything. I'm talking about the detector, the thermometer detect that like, oh, it's hot day, and then it going to talk to the aircon to ask the aircon to on and keep the temperature lower to a certain degree. This kind of a situation where we get rid of the human in controlling this. As long as all the algorithm and the whatever standard is being key in, they will execute it. It's just like you sending an email. You do not need somebody else in the middle to do this anymore. There will be a no e-post office to help you to send your email to somebody else. All these things are done by the protocol itself. And then when we come to talking about blockchain, we're talking about internet of value or internet of money, because when you transfer money or the coin from you to the other person, there is no one e-bank there to help you to clear these things. All this of transactions happens and is governed by the algorithm that's already in the system. So we call this the internet of money. So this is why internet and the availability of the internet is important. And the cost of the computing is getting lower and lower, as well as the storage. How does blockchain work? Just now we have talked about a lot about the characteristic of the blockchain, the component of the blockchain, how it's being linked together. And now here, I want to talk about how it's going to work. How's the whole process of this blockchain work? First, if you are just want to know who sent how much to who, you do not need to have an account or an address in the blockchain. You just have to go on the blockchain explorer and check the details. We're going to talk about this explorer in the second part, the second half of the day. Now, the first thing you need to do for this to be participating in the blockchain, it means that like you want to get some coins and you want to send some coins to somebody. Of course, the whole blockchain is not only for you to send coins. There's a lot more. I'm just taking this as an example because it's the easiest thing that people would understand, and the most common things people do using the blockchain. Now, the first thing you need to do is get yourself a wallet. A wallet is actually not an address. A wallet is actually just a device for you to create or keep your address. An address, as I mentioned earlier on, derives from the public key and the public key from the private key. So generally, your account is a key pair, and you will be shown the whole process of creating an account using the wallet on your first day of training on the 5th of September. But generally, just remember this. This is the combinations for your wallet, your account, sorry. So this is the private key and the public key. The key pairs generally is your account. And with that, with the public key, you already can accept whoever want to send you NFT, who want to send you any coins. Now, not exactly any coin. The coin that belong to the same blockchain that your address belongs to. I cannot send an Ethereum to a Bitcoin account because they do not live on the same world. Okay. With that, and with the public key, you can sign transactions. Now, it's just like you send any check to the other person. With now your signature on the check, that check is not going to be valid. Now, the same, when you want to send a transaction, you want to announce a transaction saying that you want to send to A 1 Bitcoin. Without signing it with your private key, the blockchain is not going to accept your transaction, because by signing it, it tells that you agreed to part with your coins and send it to somebody else. And because you sign it with private key, and your private key is supposed to be only known by you, that's proof your intentions, and nobody can forge it except you let anybody else to get in touch with your private key. And then after you have this done, because you signed already, right? Your transaction is ready, just like you have get your check done, to who, how much, and sign. Then you announce to the network. So if you have a notes, you can get it done through the notes. Or if you have a wallet, you can get it done through the wallet. So the wallet is generally just the apps to help you to do all these things. Now, after you send it through the network, one node pick up to it, and then it will propagate to other nodes. So because all these informations, right, they pick up by the nodes, we're going to share it with other nodes, right? Sometimes they also call the network a gossip network. I'm just it's like, I have to tell you something. Then what the nodes in the network is going to do is they're going to verify, does this person really have this much of Bitcoin, says, to send to A? If yes, okay, this is a valid transaction and we're going to keep it in a candidate block. Okay, a candidate blocks every of the nodes, right? Because they want to create a block for the blockchain, right? So they have this candidate blocks. It means I'm gonna have my buku 35. I'm not sure whether you guys are old enough to understand what is buku 35 or not. Those days, old day, when people like to go to the Kedai Runjit, buy something, and they only pay at the end of the month, they have a small little pocket size book. It's called buku 35 because at the front they have a 3-5, and they will record there. Okay, this month I have taken what and so whatever. And come the month end, they will do this calculation, reconciliation, and say that, okay, this is how much you owe me, and then you're going to pay when your salary is out. The same thing for this, every node, mining nodes in the blockchain. I specifically mentioned mining nodes is because the nodes in the network, they are not necessarily a mining nodes. They can be other nodes. And they'll keep, oh, you tell me that like, so and so is sending this much of coins to who? They'll keep on recording it. And then remember the proof of work that I mentioned just now, or maybe proof of stake. They'll do the calculations, or they'll run whatever algorithm they need. They'll guess whatever puzzle they need to guess. Then from out of this network, one node is going to be selected, and that node's candidate block is going to be added to the blockchain as the newest block. Now that is the role of the consensus protocol, to select one of the block. Of course, consensus protocol have other roles as well, but this is one of the major roles. Now, internet, there could be latency, right? Sometimes our internet is not very good. We get the informations maybe later and all these things. So that could be at the same time, one node is found the right equations. It says, for example, it's a proof of work. Guess the right equations or guess the right riddle. Another one at the end, at the other end of the world, also guess the right answer. They both thought that like, no, they are the one that's supposed to add their block to the blockchain, so they do. Now, blockchain, you can only have one block before your block and one block after your block. At this case, when there is a 2 block being added to this block, that's what we call a fork. It means like from one chain become 2 chain. Now, how are we going to deal with that? It's not supposed to happen. So this is the case where we need the confirmation, right? Remember just now I mentioned that, we're talking about the speed of the blockchain. If I go to the 7-Eleven and want to buy an ice cream, and if I pay with Bitcoin and I have to wait for an hour. Now, this is the times, right, where we need to wait for another block is formed. Now, when another block is formed, then this block might only recognize one of the 2 blocks being added to the chain. So it will attach itself to one of them. As time go by, these 2 blocks that added to the previous block at the same time, one is become longer because have more block recognize it and add to it, and the other one becomes shorter. The shorter one will eventually drop off, and then we remain to have one chain. So that is the reason that after you make a transaction, it's better to wait at least 6 more blocks to be formed to ensure that your transaction doesn't fall into this block that is being dropped. Of course, for you, if you are the person who sent the transaction to buy something, you do not mind even if your transactions is blocked. It means like your money is not being sent out and you still keep the product. But for the merchant, it's not a happy thing. for them. So usually they would practice of this kind of like waiting time. We call them confirmations. Of course, this is a big hurdle in business applications. If we really have to wait for this, right, that would be difficult for mass adoptions. For overseas transactions, yes, but for everyday use, it's a big no-no. So there are more and more blockchain nowadays that have shorter confirmation time. It means that like blockchain have 10 minutes per block, Ethereum 15 seconds, some of the blockchain a minute or so. Now they have getting shorter and shorter, maybe just a second for a block. So probably to wait for this confirmations, you only need to wait a few seconds. Now, so this is how the blockchain works, starting from you sending out the transactions to when the block is added to the blockchain. Is that clear for the whole process, how the block is being generated coming from the transactions to the block? Let me just look at these questions in the chat. Can we have more than one wallet? Yes, we can have more than one wallet, and we can have more than one account in one wallet. Remember, the wallet is just a device or an applications for you to execute your transactions or create your wallet. Think of it this way, like your wallet is the Google Chrome, and in the Google Chrome you can open multiple tabs. So done. Hopefully I answered the questions. From the random, so the Bitcoin and Ethereum considered as a different network? Yes, they are in the different network. So we only have to be inside the network to transfer coin. Yes, you have to be you have to have an account to do the transfer of the coins, because without the account you won't be able to hold any coin, you won't be able to own any coin. Think of the account as like a bucket or a safety box for you to keep your assets. Your asset is the coin, because without that, where your coin is going to sit, right? It's just like, if you want to go to bank, you want to transfer money to the other person, you need a bank account. So your account is just like your bank account. You need that, and then you bank in money, and then from there you transfer your money to the other person. Okay, the candidate blocks. Okay, let me explain this process again. When you want to send a transactions to somebody, you need to have an account. It's just like you need to transfer some money to the other person through the bank. You need to have a bank account. The difference that your account, on the blockchain and your account on the bank is usually when you go to the bank and you open the account, you need to have documents, and you need to put a balance in the bank, whether it's $100 ringgit or a 10 ringgit, depends on what kind of account and which bank you go to. Now on the blockchain, to open an account, you do not need any permissions, you don't need to have any documents, you don't need to even have the permissions from God, and you do not need to have a balance in your account. It can be zero balance. You can open the account just to receive funds. So that's the difference. Now with this account, you can create transactions. Before you create transactions, you need to have balance in your account. Now you can have zero balance if you just receive transaction coins in, but if you want to send, you have to have a balance in your account, at least enough to pay the transactions fee. Now with that, if you want to sign the transactions, you sign it with your private key, because your account is the key pair. It will have the public key, it will have the private key, and it's just like you're signing the check to authorize it to be sent out. After you've done that, you announce it to the network through your wallet. Your wallet is considered a light node. You send it out, and the network pick it up and propagate it. Now your transactions, the detail of the transactions, is going to it's going to record in the candidate block. Now, why is it's called candidate block? It's because this record might not get into the blockchain. It is just a candidate waiting to be selected and add to the blockchain. Every mining node in the network will have a copy because any one of them might be chosen to add the block into the blockchain and they get the incentive. So when one block is being selected and added to the blockchain, all other candidate blocks scrap and start all over again. So that is the candidate block. So once it's being selected and added to the blockchain, and the whole process is going to start again. So I hope I explained well on this candidate blocks. Just give me a yes. Oh, okay. Cool. Yeah. Is that related to smart contract? You can take smart contract like a standing instruction in the bank. Now, if you want to do a transactions, right, you probably will go to the ATM or using internet banking to say that I want to transfer money to the other person. So every time you send a different information. But a standing instructions is you already tell the bank that like, every single month you transfer how much money from this account of mine to this account. So every month, when the new month start on a certain date, this will be triggered and the transfer of the money will be done automatically. Now that is the smart contract. So for you to sign your transactions manually, that wouldn't consider a smart contract. So is that clear? Okay, hopefully Narendran, hopefully you got it, the difference. What is the smart contract? Anyway, we're going to talk more about smart contract later. Now, just now we talked about the confirmations, right? Let me just explain a little bit more here about the confirmations and something called the finality. The confirmations is called the probabilistic finality. It's because says this is the first block, and then come the second block is created. That means that like this block have one confirmation, because remember the hash for this block will include this hash, and because of this hash is in here, they link, and if anything changes here, it affects this one. So it makes information here harder to change with this block added. Now, when this third block come along, it will include the hash of this. That also means that it includes the hash of this. When this block come along, it makes this second block harder to be changed or edited, and it makes this block even harder to be changed. And then come this fourth block, same. It includes the hash from this block, this block, this block, and then it make it harder to change, harder to change, harder to change. Okay, you get what I mean? As it go longer, it get harder for any hacker to change anything, because if you change anything here, you have to change every single hash in the following blocks. Not only that, you have to change the informations in every other nodes in the blockchain, at least 50% of it. Now this is called the confirmation. Another thing is called the deterministic finality, is what we call the finality. It usually happens in a proof of stake, where after a block is being created, there will be another subset of nodes is going to come and vouch, saying that this block, we accept all the transactions in here is correct, and this is it. we're going to chop and say nothing's going to be changed. So this is called the deterministic finality. Usually it will be faster because once you create the block, the next thing they do while you are creating the second block, they will go ahead and start the finality confirmations. So this is the difference between the confirmations and the finality. As of now, let me see if there is any questions. So if I want to send the coin to different vendor, he or she needs to wait, is it? Cannot be at the same time. Okay, let me just explain a little bit more why the person need to wait. Now, when you send the coin, usually it's quite instant. There could be still, maybe you need to wait a little bit because of the block creations. Remember, let me just go back. Here. When you send the transactions and it's being picked up by the network, and during that time, they are creating the candidate block. Now, when they create the candidate block, each different blockchain would have a different block time. What is block time? Now, Bitcoin create a block on an average 10 minutes. Ethereum create a block in an average about 15 seconds. That is the block time. Now, if I send you a Bitcoin when the new block just created, the next block I might need to wait a few minutes or even 10 minutes for my transactions to be included into the new block, because every 10 minutes, right? And when the block is closed, only my transactions is being included in the block. And that is not enough because there could be two blocks being created at the same time, and maybe my transactions is being recorded in both blocks because every nodes in the network would have the candidate blocks and would have picked up as many transactions as they want. So my transaction may be in both the block, maybe only in one block. So as time go on, right, one block have a longer chain, another one may have a shorter one. And if my transactions only in the shorter chain, so my transactions will be dropped together with the block and into the pool again, waiting to be picked up by another block. That is the reason that we need to wait for this confirmation. So we know that by that time, the shorter chain would have already dropped. Narendran, I'm not sure whether I answer your questions. It can be at the same time. It all depends of the time you send the transaction, whether it is the time that the block is being formed. So if you are on the block, sending it on the blockchain that have a very short period of block time, for example, 5 seconds, says, that is almost sounds like an instant. When you send the transactions, the other end will receive it right away. Okay, cool, thank you. Okay, another question is it depends on the candidate block whether to accept or not, is it? Yes, it depends whether the candidate that is accepted to add into the block, whether your transactions is in it. Now, another issue that your transaction might not be included into the block is because it could be the network is congested. It means that at that period of time, a lot of people are sending the transactions, and there is a limit, a limit to a block. For blockchain, that's the size of a block. For some blockchain, could be a different way of limiting the transactions in it. Not all the transactions will be collected in, will be included into the block. Now, how the node select the transactions? go by the transactions fee. Now, we talked about the incentive just now, right? Why they want to run the nodes? Because they want to be incentivized, right? Of course, one of the incentive is coming from the transactions fee. So the higher the transactions fee for the transactions, the more likely your transaction will be included into the block, especially during the high traffic time. Now, if probably you have heard of it, that just increase your gas fee or your transactions fee, then your transactions will go through faster. Now, that is the reason. If your transactions fee is low, your priority will be low. People will, the nodes will usually the nodes they tune it to pick up those higher transactions fee first. So those lower transactions fee one get pushed. So if your transactions is not urgent, it's okay. But if you need it to be urgent, yeah, you need to jack up your gas fee. And that is the reason why sometimes people say that, like, the gas fee is higher than your whatever amount that you need to send, especially when you are sending over a small amount of sum. Yeah. And who will approve the candidate blocks? Hold on, let me just go back. The consensus protocol. Okay, it generally is part of it, because remember earlier on I mentioned, if for proof of work they are using this ASIC, is the specific computer made to do the mining because of their high computing power, is because they need to keep on guessing the right answer. And when they guess the right answer, their candidate block is being selected to add on the block, and they get the incentive. So who approves the candidate block? Generally is yourself, if your computer or the nodes is powerful enough to be guessed a lot more times than others and get a higher chance to get the right answer for it, then your candidate block is going to be picked. When the nodes gets the right answer, the candidate block is being added to the blockchain, right? So who approve it? So it generally is in the algorithm. It's already set that it will run on its own. As long as your nodes get the right answer, you'll be selected. So the mining, okay, how mining works? I have just explained actually. Mining is the whole process of the network. Okay, if you are running a mining works, the time you pick up the transactions that announced by the account to the network, your process starts. So the process as shown here is the whole mining process. So the mining is not only about minting the coins, it's the whole process of you pick up the transactions, put it in your candidate blocks, and then you participate into the process of, either in the raffles for POS or guessing the right answer for POW. You participate in that, you got selected or other people got selected, and then the block being added to the blockchain. The whole process is the mining process, and the outcome of it is you get rewarded by the transaction fee as well as the newly minted coin. So is it clear for the mining process? So sending transactions and mining undergoes the same process. Once you pick up the transaction, I would consider that the mining process starts. You as a user sending the transaction is you just sending the transaction. The person who sent the transaction do not actually participate in the mining process. It's just that like the transactions is sent out and the transactions fee is going to reward the persons who mine the block. Like we it's like we do mining like the iron ore or the gold, right? The process of like correct you what correct suddenly I cannot remember what's correct in English, but anyway you know what is correct, right? To dig, okay. The process you start to dig, yeah. The process you start to dig the iron ore, and then you dig the dirt, and then you found the iron ore, and then you extract the iron ore and process it. So the whole process is called the mining process. The same over here actually. Earlier on we talked about why use blockchain, because we want to have trust within these two parties without the third party, right? So how the trust is being created? Just by using these codes, those algorithms, right? First, we use the cryptography, the key pair, where you sign the transactions with your private key, and that is very unique. It's almost like your digital fingerprint. It's not reverse engineeringable. And then it's transparent because all the information is being shared to everybody in the network. And then it's also timestamped. And all this come together make the informations immutable, or at least 99.999% immutable. In theory, it's possible. In practice, quite impossible, except your network is very small. So the security of the blockchain is actually lies within the size of the network. It lies within the redundancy of the database, because when the network is big, there's many copies, so that makes the security for the blockchain. And when this trust is there, because we know the network is big, we know that like, it's very difficult to change anything, so we trust it. We trust that like if the network say that this person have this much of coins, I would trust that is true. Then the transaction with these two party do not really need the third party. Plus, when the smart contract come in, the trust is even more, is because now we do not have to say that like A and B is going to deal, so A should send the transaction first, or the B should send the transaction first, because things can happen atomically, that the transaction can happen at the same time. The blockchain can do the escrow. We do not need to have a third party to be at the escrow. Okay, about the proof of work. Proof of work is part of the consensus protocol that is used by the Bitcoin blockchain and many other blockchain, including Ethereum. But Ethereum is soon going to move on proof of stake, but it's on most of the blockchain on the early days is on the proof of work. So how proof of work works is this number of nodes in the network. There is no one main server or the rest is client. No, everybody is the same. So who is going to make the decisions? There will need to be a mechanism to make a decisions, right? The decisions including that the transactions is being announced to network, everybody pick up. You need to check whether this is check the history, right? Whether this transactions is valid or not, whether the sender does have the balance of the coin to send out or not. So this is the first things the nodes need to do, and that is part of the consensus, means like agreeing that this person have enough balance. Then while they are accepting the transactions, the one thing that all these mining nodes also do is doing the computing. What they are computing about is, like I mentioned earlier on, there is like you can take it like a puzzle up or a riddle that they have to solve, or like a puzzle that they have to find the right feeds to fit in, or equations that they have to guess. Just think of it something like this. So they have to keep on guessing. The only thing and only way they can get the right answer is by guessing it. Because again, using the example of 2 plus 2 equals to 4, if I give you 4, they have to guess the equations. The only way they can do is by guessing. The stronger the power of your computer, the more times they can guess, the higher chance they can get the correct answer. Now, because the computer, right, has to keep on working very hard to find the answer, so they actually work to earn the incentive, because when they guess the right answer, their candidate block gets to put as the next block. When your candidate blocks accepted and put it as the next block, you get the transactions fee in all the transactions you picked up and put into the candidate block, as well as the newly minted coin. So this whole process, which is the mining process, and using this computing power, is called the proof of work. Okay, Narendran, did I have you understand more about the proof of work? Next, we come to talk about the blockchain architecture. Now, not exactly every blockchain is going to look like this, but it won't run too far away from it. First, whatever we see from the outside, we talk about is, now first, we if we use a wallet, take for example, because that is also an app. If you have used a wallet, it's like a applications. Now that is the presentations or application layer, and sometimes it could be a web app, and some of the functions could be a bit like the web 2 applications. It's just like your normal web applications. The only difference is that it's connect to the blockchain. That is the first layer. That could be a D app, just like a wallet, and that is what the UI you see. Now, when you take the wallet as an example, that is the first layer. Now, how it's going to come to talk to the network? There will be most of the blockchain now does have a set of the API for different languages, and that is the layer they connect to the blockchain itself. Then it comes the consensus layer, as we talk about the how your transactions is being validated and how the candidate block is being chosen. So you can see that the architecture here, it relates a lot to how the blockchain, the process of the blockchain, how the block is formed. They come to consensus layer. Now, when at this consensus layer, at the same time, there will be this network layer, which is the peer-to-peer network. What they do is they validate your transactions using this consensus layer, whether it's proof of work, proof of stake, delegated proof of stake, etc. And then this peer-to-peer, this layer of the network, they are also propagating the informations, either sharing the transactions they pick up or sharing the block that is being formed, because they need to distribute to everybody. And then it comes the data layer, where it keeps this information that is being recorded. And this is why sometimes people ask, is blockchain just another database? Because yes, it keeps a lot of data, and it has this data layer where it will, all your hashes of the transactions, the hashes of the blockchain, and the informations are being kept. And the linkage and all these things is using what we have discussed early on, the Merkle tree. And some blockchain might use Patricia tree as well, and maybe add other way, and some extra informations here. Blockchain is a distributed ledger technology, but it's not all distributed ledger technology is blockchain. Now, some of the distributed ledger technology might not form blocks. It means like every single transaction is linked to another one by itself, and that is called the DAG. Okay, this is the dynamic acyclic graph. Okay, that is beside the topic. It's not to cover today. Just some extra information to let you know not all DLT, distributed ledger technology, is blockchain. Okay, that's why they could use different way of linking the data other than the Merkle tree. And then it comes the layer, which is the hardware layer, which is when we talk about smart contract, we'll talk about the virtual machine and the container and how those like protocol, the message is being sent within each nodes. Now, this is where we talk about like the nodes, the machine we need for the nodes. So generally, those are the those are the components that structure the whole blockchain. If you go to some of the sites of different blockchain, the way they put it might not be this way. Some they will just do not have this. They do not mention about hardware level, but that is kind of like, you need the nodes. The hardware is going to be there. It doesn't matter whether you are using the cloud or what or having the nodes on your own premise. You still need that, right? You still need the virtual machine to run it. And sometimes you'll see that like another API layer being mentioned in some of the blockchain network when they're talking about their blockchain architecture. Now, which is true as well. So this is just an idea for you that like how the blockchain is architected in general. If you read here, I said that it is not a contract, it's not the smart at all, which is kind of true about smart contract. It's not that like smart contract is not a contract. It generally do have whatever a contract needs. In a contract, there will be more than one party. So if you are making a contract within to yourself, right, you don't need to actually make a contract. That's called a journal or diary. You just tell yourself that like, I promise myself to do this and that. You don't need to enter into a contract, right? You enter into a contract because two parties have to come together and agree on something, and we put those things down, and then it's enforced. If you want to be enforced by the law, you need to go and do some notarizations, right? So a contract usually would have more than one party, and then you will have offer and acceptance. So what is this contract is about? So if there's nothing that like you offer to me and I need to accept, right? There is no point to go into a contract either. And then you have to have the consideration. The consideration means that if I offer you this apple and you accept it, what are you going to give me back in return? Right? Okay, you're going to pay me 1 ringgit for this apple. That's considerations, right? Capacity is whether I will have this apple or not to offer to you. If I won't be able to grow this apple, or I won't even be able to source this apple, then I do not have the capacity to offer you this. Then this contract is takkan jadi, right? And the legality. Is it legal for me to sell you apple? Well, selling apple, of course, okay. But if it is not legal to sell drugs, I cannot put in contract saying that like if I sell you this much of drug, you have to pay me in this such. It's not, right? So contract generally would have all this kind of terms that you have to to make it a contract. Now, put it into a smart contract. It's the same. If you only need to send some tokens back to yourself. When I talk to yourself here, right, it means the same account, not like you yourself might have two accounts and then you want to have a smart contract to automatically send some tokens to the other account. That's okay, because it's considered still two parties, right? You need to have a receiver, or even though that like you want to burn this coin. When we say burning this coin, it's just like, throwing your money into the sea and nobody can find it kind of situations, that the sea is still the recipient. So you need to, for the smart contract, you need to have like a recipient. And an offer and acceptance is generally is like, if I offer to send this token out, I need to sign using my private key as well. And the other end generally also need to the other end generally here doesn't have to accept that is a consideration, that is something that I have to done in return. Then the other side also have to sign with their private key. Then that is what I call earlier on the escrow. You don't have to worry that if we have this deal going on, whether party A need to send the transaction first, or the party B should send the transaction first. Says that like party A is going to sell an NFT to B, and B is supposed to pay some Ethereum, right? Okay, so that is the case. Then when they have both accepted it, right, and the considerations is one NFT for how much Ethereum, how much Bitcoin, or how much Algor, then they are going to get into this contract, and it have to have the capacity. It's just like just now someone asked that, like, how we know that, like, whether the person have this much of coins. So the system is going to check the capacity, whether they have the balance or not, whether this person would have the NFT, whether the buyer would have enough coins to pay for it. And legality in terms of smart contract is whether it is valid in this blockchain or not, right? So if it's not valid, it means that like the blockchains, the nodes is not even going to pick it up to put it into the candidate's block, because to run the transaction, to execute the smart contract, to execute this smart contract, it's still going through the transactions. You still call the transactions to execute this smart contract. So you can see that like our normal contract and the smart contract actually have a lot of similarity. But why I say that like smart contract is not a contract, it's because smart contract is not our normal contract that can be enforceable by law, at least not by law, not now. It may be in the future. It is enforceable by the algorithm, the law of the network itself. So don't take it as if the smart contract can replace the contract we have nowadays, saying that like, okay, I don't need the contract, I have the smart contract. The smart contract is only going to execute whatever on the blockchain. It's not going to replace our contract. So it is a smart contract, but it's not our normal contract. It is not that smart. It's because you still need to give the instruction in order for it to work. It won't be like your lawyer to suggest to you, to advise you that like, probably you should do it this way, probably you do it that way. No, you have to instruct for it to do whatever you want it to do. So if you ask it to do some dumb thing, then it's going to do the some dumb thing. If you ask it to waste your gas fee, it will waste your gas fee. So that is why there are people say coding smart contract is difficult. Coding smart contract is actually not difficult. It's pretty easy. It's how to code a good smart contract that is difficult, because we're going to talk a little bit next. Okay, Let me just check if there is any questions about the smart contract up until now. Okay, nothing. I'll just continue. So, in traditional contract, we have the parties come in to say that, okay, let's come and do this deal together. And we form the contract. We have the third party and lawyer to read through for us. We go to the LHDM and have it chopped and notarized, pay some stamp duty, and we go on to execute whatever we promise each other. And in the smart contract, generally, it's like two of us come to an agreement, and then we go on to the blockchain, whichever we choose, have our own account. We go into this smart contract. It's either that, like, we have a customized smart contract for our own project, or there are some standard one applications out there. For example, if you are selling an NFT on a marketplace, that is a smart contract already there for you both to execute your deal. So you go on to the smart contract, agree on the deal, sign your transactions, and the smart contract is going to execute for you. So in this case, you get rid of the third party. It's just like, when we talk about earlier on Internet of Informations, it get rid of the post office, and you can send email from one person to the other person without any third party, without an e-post office. And when it comes to Internet of Things, the one device can talk to the other device without the interventions of the human. And when talk about like Internet of Value, we can send money from one person to the other person without the bank as an intermediary. As a smart contract as well, an agreement between two parties can be executed without the third party, the lawyer, as the intermediary or the escrow company to act as the middle persons to get this deal done. So this is generally what smart contract does. Now, as you go on to code smart contract, there are some common mistake or errors. Not only like after you deploy, sometimes like as you code and as you debug and all this, this could be something that like you come into. You could meet with this error or mistake. The first one is very common. Sometimes you just forgot. It's the incorrect calculation of token output amount. What I mean that is there is no decimal places in the number. So if I want to say is $10.10, I generally I'll put 1010, and as you do your front end, you pick up this information, you need to put it into you need to put in the right decimal. So sometimes you just forget to adjust this, and somehow the result come out and say that, hey, why it doesn't appear as what I expected. So you probably just have to go back and check on this. Now, insufficient token. This is a very common mistake that we went into, is also that when you do testing, you sign a transaction, you announce it, then you say that, how come this transaction is not going through? Matter of fact, you go and check is because in your wallet you have no sufficient tokens to pay for the gas fee. Things like this will happen. And or else, like sometimes, right, I think if you have do enough coding, I'm sure you run into the times where you write some loops and you did not get out of the loops, and then you just keep on executing, and you just have to force quit it. You have to force it to stop. But for smart contract, once you deploy, there's no way for you to stop it. The only way it will stop is when your funds run out. Imagine that if you have a huge amount of funds and this smart contract is not running on the test net. A test net means that, like, the sandbox that, like, you test on before you deploy your smart contract on the actual main network. Your fund is going to be gone. It will just keep running until that your fund is gone and there's no fee to pay for your transactions fee, and that is pretty painful. And the dependency on the order of the executions, I think this is also quite common, that when you are uh, uh, coding your any of the app, and sometimes it could be dependency of some library. And time component is when you send any transactions, you need to put in the timestamp there as well to say when you send these transactions, so that, like, we know the sequence of which transactions happen first. Now sometimes, because of the clock, there will be some discrepancy in the timing, and ended up that the transaction seems to be too far into future, or it just not really matching the network time. And usually the blockchain, the transactions times, already the blockchain time, not the block time, I'm talking about, like, for example, like now is 1 p.m. 45 minutes. Generally, the blockchain time started to count in second, starting the time the first block is started. It means that, like, the first block is being mined, that is where the clock start to tick, like 1 second, 2 seconds. That's how it goes on. So you probably will understand more when you come into this coding, when you come into this, because sometimes when you do the sometimes when you do the coding, you will need to pick the time from your network, and sometimes the latency could cause this to happen. Now this might not be the issue also when they come to this smart contract that you are going to study. So don't worry too much about it if you kind of, like, don't really get what I mean. You will understand better when you hands-on, especially when you run into this issue. The smart contract differ from each applications. Narendran. Okay, I do not sure if I understand your questions correctly. But, you means that differ from each application. Says this wallet, or for example, okay, not use the wallet. For example, this NFT marketplace A and this NFT marketplace B, are their smart contract different? Yes, this could be different. So it doesn't mean that, like, you are minting your NFT on the marketplace is actually exactly the same as the other marketplace. Now, their standard is going to be different. Their standard is going to be the same. For example, on Ethereum, they are either using ERC721 or ERC1155. So whatever is required by the standard, they have to have it on the NFT, no matter you mint it on marketplace A or marketplace B. But the smart contract they use to mint it could be different. For example, this marketplace A might only let you have royalty of 5%. This could let you to have, like, different of, like, 10%. And how they channel the tokens of your cells, it could be different also. So don't ever think that As long as it's NFT, everything will be the same. The only thing that must be the same is their standard or the properties of the NFT. Narendran, is that what you mean? Is that the rules? What the rules that you mean? I hope that I get what you mean and answer your questions. Yeah. Okay, cool. Thank you. So yes, different marketplace will have different. So as like if they say that like, oh, this DApp also meant for escrow. This DApp is also meant for escrow. For the user, there could be no different. But for people who at the back at the back end, like developer like you guys, you would find out that is different. Okay, now let's move on to crypto asset. Now we talk about crypto smart contract. Why smart contract is so important? Because smart contract is also help us to create fungible token and non-fungible token. These are the two main category of assets on the blockchain. Fungible tokens, it means like our cryptocurrency or our stable coin. One token is no different than the other tokens. Their value is exactly the same. It's just like you have 100 ringgit, I have 100 ringgit. Even yours might look newer and mine looks older. If we exchange our 100 ringgit, you still have 100 ringgit, I still have 100 ringgit. There's no difference in the value. This is the fungible tokens. This is the cryptocurrency. And the other one is the famous NFT, non-fungible token. You can imagine it like a passport. Your passport and my passport look exactly the same because we are coming from the same country, same thickness. The information category inside is the same. Yeah, there will be name, there will be address, there will be expiry date. But all the informations in this fields are different. If we exchange our passport, your passport is not going to represent me, my passport is not going to represent you, and it's even illegal to hold other people's passport to go through the custom. You won't get through. So this is the non-fungible tokens. And you need the smart contract to mint the fungible token or the non-fungible tokens. And with the smart contract, you can do a lot of customizations to your fungible tokens and your non-fungible tokens. Right? So again, to summarize it again, fungible token is the asset class on the blockchain and is identical. For Ethereum, the standard is ERC20, and many other different blockchain would have different one, right? And it's transferable. You want to tokenize your assets. It's because you want to make them easy to be transferred and traceable. And it is because it's traceable. Again, remember we mentioned early in the morning that because all these are open, it's recorded and make it traceable, and that's why we trust this network. And non-fungible token is one of a kind, and usually the standard on the ERC is 721, ERC 1155. The reason that I mention this is because a lot of other blockchain would take this standard as a reference to have a similar one. Now, why other blockchain would make reference to this is because we are talking about interoperability between the blockchains. So if one blockchain have like a very different standard than the rest of it, it's very difficult for the blockchain to be able to interoperate with the other blockchains, and that means that like it's difficult for them to participate in this game, and people want to be able to interoperate. Now, I'm not sure. I'm actually pretty sure you guys never experienced this. Is when early days when the mobile phone is getting more popular. we only can send SMS to the number that at the same network. It means that if I'm using Digi, I can only send SMS to Digi. If I want to send it to um, Cellcom, I have to use another application to bridge it. So mafan, right? So difficult, right? But now there's no problem. You can send SMS. People don't even want to send SMS anymore. We use WhatsApp and other messaging applications, right? So this is the progress. If the telco is not, suddenly there's one telco that say no, I want to have my own system. I do not want to, you know, conform to the standard. Then most likely people are not going to want to use that, right? Except that, like, their service is very good or the price is very competitive, or else there's no reason for the user to use it, because that means they can only probably call or SMS or communicate within their network, not with the rest of the network. So interoperability is very important, as it has been an important topic. So questions. So the NFT breaks the barrier between different crypto network? Not really, because NFT on Ethereum is still NFT on Ethereum. NFT on Algorand is still NFT on Algorand. NFT on Solana still NFT on Solana. There might be it's not like cryptocurrency where you can wrap the cryptocurrency and consider that you exchange it with another tokens, but that is also almost like says if I want to exchange my Bitcoin to with your Ethereum, generally it's like, we both have accounts on Ethereum and Bitcoin, and then we do the switch actually within both network. It's just that, like, that is a bridge to bridge. That's why we call it the wrap token. NFT is more complicated because it's not really identical. If you have an NFT on Solana and you still have the same NFT on the Algorand, it makes the NFTs not unique and probably drop in value. So no, NFT is not, it's not meant to break the barrier between the crypto network. Mainly if you say you want to have the swap between different tokens within the different network, yes, this make more sense. Okay, fungible tokens and non-fungible tokens, when you come into the property and how they're going to be recognized is in a smart contract. When you create this smart contract, says I'm going to mint 100 tokens of this fungible tokens, or 1,000 of this, says this smart contract you're going to mint 1,000 fungible token named CTC. So after you create this, right, in that address that call to this smart contract to mint this 1,000 tokens, will have this 1,000 token in the address. You see, you have to have an address, which is the account, to call any transactions, including the smart contract. So once this smart contract is being called by this address, this 1,000 tokens is going to be into this address, and once this address send out one tokens, or however many tokens, to another address, here for example is I send one tokens out to Alice, then in the map it says, like, the original address still have 999 and Alice address would have 1. So this is fungible tokens because all these 1,000 tokens have the same value. For the non-fungible tokens, says I want to mint 1,000 of these CTC non-fungible tokens. So then each of this token would have a number from number 1 to number 1,000. So in my address, I could have mint one first and is minted by my address. So it will be in my address. Then Alice might call the same smart contract and mint another one, and that would be that, and that NFT would go into Alice's address. So it's just like, for example, the board at the board at your club. There could be, for example, just take for example, this 1,000 of it. So the number one looks like this, the number two looks like this, but they are all using the same smart contract. The only thing different is the uniqueness of each of this token. The general traits of the the general traits of these non-fungible tokens are the same as long as they are coming out of this smart contract, but each of them would have a specific numbering to it. Is that clear on this part? Can I have an okay or yes if so far from the lunch until now you at least get 60% out of it? Can give me some feedback? Yes, okay. More, so that I know that it's not the minority. I'm not talking to myself. Okay, cool. This one up until here, this part is quite important because this is a general concept how the fungible tokens is different from the non-fungible tokens. We have talked about the smart contract. We have talked about like the difference between the non-fungible tokens and fungible tokens, and all these tokenizations generally they have these four main functions. It's not limited to this. Generally have these four main functions. The first one is stablecoin. We have heard of USDT, USDC. So this kind of coins are generally packed with the coin that they want to pack with. For example, USDC to USD. The utility tokens generally is just like the coin that are out there mostly are utility tokens. You can use it as money, or sometimes you might use it for some services on that applications. So generally, utility tokens are the most common one, meaning that you use this token for some other purposes. Another one is governance tokens. We talking about a lot about distributed autonomous organizations recently. It means that it is a community that gets into this smart contract where it would let you to make decisions according to whatever preset rules and regulations you have. You just put it into the smart contract, and within that, if there is any decisions that need to make, you will need to vote. How you're going to vote is in this DAO, whoever holds the tokens, you would have the voting rights according to however much you hold. Now, it's not necessarily have to be that case. There will be different ways of how you want to give the governance tokens. There could be DAO that use whatever token that is issued by them, just proportionately. That as long if you have 50% of the coins, then you have 50% of the vote. So generally, you make the decisions, but usually this kind of DAO will not be favorable because who want to have one person make the decisions, right? And that is not the spirit of, or that is not the what blockchain is advocating for, right? There could be other way that each of the person who own an NFT would have one vote. And in this case, an NFT almost act like a membership. As long as you are in this DAO, you have our NFT. you have a voting right. Does one NFT always equals to one vote? Again, it also depends how the DAO design at the very beginning. So there is no hard and fast rule about this. Just that you can you can do it this way, or you can always create another token just for the voting purposes. The other one, the most common and what we understand the most is the tokenizations of a one of a kind item into an NFT. For example, an art. It doesn't have to be digital art, it can be a physical art, and you can even turn your car into an NFT. You can turn your property into an NFT. The most important is how you link this NFT to the car, to the property. The property is pretty easy. Probably I'll just put the grant number in the metadata of this NFT. Now, but let's have another issue. Is that would the government or our legal system accept this? Right? We are talking about like the possibility. There are still many other issues that we need to take care of. So tokenization is not something that is a very new idea. Just want to take for example, if you go to give some talk or you volunteer something, at the end of the day, sometimes you will get a tokens of appreciations, right? Appreciations is something that is very intangible. So in order for us to make it tangible, right, we buy some gift to show as our appreciations of the person. It's almost like we tokenize our appreciations, right? So in blockchain is kind of the other way around. We probably have something that is tangible, like our house, our car, our art. And because we want it to be easier to be transferred the ownership to another person, we tokenize it and put it on the blockchain. And from there, we can exchange the NFT maybe for cryptocurrency or an NFT for another NFT. So that is the idea of tokenizations. So if there is no questions, let me just move on to the challenges that we face and the blockchain. We call it the blockchain trilemma, which is I think is quite similar, very similar actually, to the trilemma you would face when you are building applications. You either get it cheap, you either get it fast, or you get it good. So if you want to get it good and fast, you have to pay more for it. If you don't want to pay more for it and then you still want it good, you probably have to wait for a long time until the programmer is free to do your stuff. This kind of things. In blockchain, we call it the blockchain trilemma, and the three things is decentralization, the security, and the scalability. Now, if you want it to be very centralized, then probably you'll suffer the scalability and maybe the security. And if you want it to be very secure, right, then you may suffer the scalability because you definitely have to have it to be more decentralized in order to be more secure as well. So let's talk about the decentralizations versus the security. When we talk about decentralization, it means that as there as many nodes and as distributed as possible, that would be more secure. Even though that we say we can have different nodes, but sometimes a lot of the nodes might be controlled by a group of people and they will have unanimous agreement or actions. That makes it not so decentralized already, right? So then when it's not so decentralized, it means your security is a bit worrying, right? Because it says three big group together. Here, three big group come together is 50%. As long as these three come together and they buck up and say, okay, we want to overturn whatever they say over here, they probably will win. Hence, whether a network is secure, sometimes it lies a lot on their number of nodes and how decentralized these nodes are. And we talk about the decentralizations versus the scalability. Now, we want it to be as distributed as possible. It also means that the disseminations of the information need to be very effective. And it means that it need to have a bigger network for more security. And that also means that how soon, if there is any changes or any upgrade to the system, upgrade to the system is not like not possible, it's just difficult. That's why Ethereum, their upgrade takes times and a lot of effort. And because of this, it make it a bit difficult to scale. It's not like not possible, it's still gonna be more difficult. And talking about the speed, we are talking about scalability, for example, about proof of work, because all the nodes in the network need to compute and they kind of like fight against each other for the speed to get the, to guess the right answer. Not only that, that is also about propagating the information to the network. So all these kind of things would kind of like because of the size of the network, the propagations sometimes depends on the network might not be as quick as we thought. Probably it will be much better and the infrastructure improve. But at some point, sometimes I think as of now, we can still say that like that is still a bit of the concern. Coming back that a little bit is, in order to get a better, a quicker consensus, earlier on we talked about the confirmations and the finality, right? In order to get a quicker finality, some of the network could have only a subset. It means like a percentage of the whole network to validate on this finality of the block. Generally, as of now, we don't see a big issue, but that could still be considered a less decentralized solution. This is not something that like you need to worry about when you are learning the smart contract. It's just that as we talk about this, I think it's a good topic for us to ponder upon. Because sometimes this issue, when they come to building the smart contract, which blockchain we would like to choose is also part of the concern. If you would like to have the speed, you probably need to forego the security or decentralizations. So far as I understand, or I do believe, security wise is still quite okay for most blockchain. A lot of the times the hacks that happen may lies on the smart contract. As those mistakes I mentioned earlier on, there could be something that you do not realize or do not test enough when you are building the smart contract, and the hackers see the opportunity and they exploit it, and that is where the fun is gone. So as a smart contract, developer, your responsible is quite high as well, and that is also the reason why usually a good smart contract developer would fetch quite a good income. That comes with a lot of experience you need as well. Now, just now we did touch on the interoperability. Um, a lot of blockchain would have some sort of interoperability now, either really using the wrap coins concept, using the bridges as well. We're not going to talk too much about it here because this is more towards building the blockchain rather than building the smart contract. But I do think uh, this is a very important factor to this is a very important point to understand. Just like I explained earlier on, if there is a telecom that would like to have their own way of doing things, they might not be very popular. Now, talking about like Algorand that you guys going to learn of the smart contract, they are using a different protocol called Pure POS, where generally the trilemma that blockchain are facing is getting it is not as what do you call that? It's not as serious. No, what do you call that? I lost my word also. I want to say Katara. So what Katara means says in English. Sorry, I'm kind of like keep on having the Malay terms in my mind today, but the English was just not coming out. Yeah, so it means so the way they're having their consensus protocol would have a little bit difference. They also have validators to have the finality to mitigate the trilemma issue. You would probably get the feel of what I mean as you go on to learn about the smart contract. So don't worry too much about it if you kind of like, how it's gonna happen. I'm pretty sure you will run into these problems, and when as you're solving it, you will understand better uh, what it is. Now, another issue that is like might not really be the trilemma is storage. Other than like the storage is getting cheaper and it's more affordable, still, if you're just starting a new node, like for example, blockchain have been running for 10 years and you're starting a new node, downloading it, the history is going to take you some time. I'm not quite sure how long it's going to do that now. So they have a different way of settling this issue is either to have a dump that you can download it faster, or like a snapshot, or sometimes is there'll be some data pruning. Different blockchain would have different way of reducing the storage space. So this is just for information. It's not something that you need to know at this stage. So we talk about like all those challenges that we have. What are the possible solutions, right? If you have heard of like some layer 2 solution, layer 1 solution, layer 0 solutions, or other DLT. Now, other DLT is probably just not using a blockchain technology, but still a distributed ledger technology. The difference is they don't form a block. So that is just for your reference. Now, when we talk about layer 2 is when it comes to talk about the scalability, and sometimes it's also because of the cost of if I always says me and Alice always go out to eat together, and we want to pay by using cryptocurrency, says Algo, the coins for Algorand. Then we have to pay a lot of transactions fee, even though it's a small amount, right? Because every day we go out to eat, and sometimes, right, at least I pay first and Alice have to pay me back, or sometimes I pay first, Alice pays first, I have to pay Alice back. And in order for us to save on this transactions fee, we can have like a sidechain or a lightning network where we kind of like take this, me paying Alice, Alice paying me, off chain. Is like we have our own buku 35 that, like, every month Alice pay me, I pay Alice, until the month end only we take the balance. Maybe I owe Alice or Alice owe me. Then on the actual chain, Alice is going to pay me back the balance if at end of the day Alice is the one owing me. So we would also solve the issue of too many transactions congesting the actual network. So it also partly solving the problem of the scalability. So the blockchain don't feel so heavy. And other layer 1 solution is what Ethereum is proposing for the Ethereum version 2 is sharding. I think that if you all are familiar with a database, you would know what is sharding is about. So what sharding is, for I take Ethereum for an example, is when you have these transactions coming in, I'm not going to ask all the nodes in the network to verify it. I'm going to ask only, for example, only 1/3 of the number of the node is going to verify this. The other third is verify other things. The other third is verify the other things. So then it will make the network be able to work on more transactions per second. And you do not have to propagate the information to all the nodes in the network. And you do not have to get the consensus from all the nodes of the network. So it scaled it up by making it faster. Rollup actually have a similar idea, that almost like you take certain things, the work off the chain, of that layer 1, the mainnet. You have all these calculations you need to get done off the chain, and later on with the result you roll it up back to the main network. So in that way, it's also lessen the burden of the main network. Now on the layer 0 solution, it's almost like a relay chain. It's almost a relay chain for the upcoming Ethereum, or the parachain for the Polkadot. This is coming to the sharing the consensus. For example, this is coming to almost like sharing the consensus, for an example. So I'm gonna stop the explanation here for that. You just have to understand that, like, it come to the consensus layer. It is even more deeper than the layer 1, because if I go on to explain, they will probably have to explain, like, how Polkadot works. Okay, I see your questions. May I know the transactions fee is paid to who? Okay, it comes back to just now we're talking about how the blockchain works and the mining process. The transactions fee is when you announce the transactions, you need to put in the transactions fee. The higher the transactions fee, your transactions will get included into the block faster. Why? It's because your transactions fee is going to use to incentivize the nodes. The nodes mean like whoever set up the computer that run the software of that network. They are going to pick up the transactions with higher transaction fee because that is what it's going to pay to them. Then if their candidate block is being selected to put to the chain, they will get the transactions fee that is paid for it. So the answer is the transactions fee is paid to the nodes whose candidate block is selected as the newest block. Let's continue. Talk about wallet, account, and address. Actually, this I already mentioned earlier on in the earlier when someone asking, can you have like multiple wallet? Yes, you can have multiple wallet because even for example, you have like Trust Wallet, you can have it or MetaMask, you can have it a mobile on your desktop or sometimes even as a Chrome extension. So you can have a multiple wallet, and you can even have your address in different wallets. As long as you have your private key, you will be able to see your account, the assets you have in your account in even the Explorer, in different wallets, and even if you just want to check on it using a CLI. Okay, so the most important thing is do not lose your private key. You can imagine that wallet is almost like an ATM machine. When you can use the ATM machine, right, to check on any of your account, or even other people can use the same ATM machines to check on their account. Don't do the practice that like, okay, let use other people wallet to log in using your private key and check your thing, because if you forgot to log out means the person will have your private key as well. So yeah, don't do that. But just imagine this is how the case that it almost like an ATM. You can, as long as you key in your password, you'll be able to see that like, how much balance you have from there, and you can transfer money to the other account through the ATM as well. Different from the ATM is like wallet can create your a new account for you, and you cannot do that over the ATM machine. Okay, and account is, like I mentioned earlier on, is the key pair, and the key pair is the private key and the public key, and the address is the extension of it that tell you more about this account, which network it belongs to, and either it's on the mainnet or on the testnet. Sometimes they might have the differentiate. It's not necessarily have the differentiations. It depends on the network, but most network would have the differentiations. Okay, again, not your key, not your coin. So if you lost your private key, say bye-bye to your coins. So what actually is a wallet? Just a recap, whatever I have said, you can use it to create account, to sign transactions. Okay, you don't have to use a wallet to sign transactions. You can use CLI or whatever way, but wallet is a simple way, right? Why want to go through the hard way? Except that like you want to send the transactions, like 1,000 transactions, then probably it makes sense for you to use a CLIs to generate your own code. But wallet is good enough. To use it to calculate your gas fee, some wallet might let you do that, because like the gas fee or the transactions fee is not fixed. Sometimes it all depends on the traffic, and also whether you want to top up the transactions fee to make sure that your transactions get included into the block faster. Displays the asset, so it's just gonna let you check how many coins or how many NFT you have in your address. Some allow you to do some staking from there or swapping. So the account is private key, public key you use to sign the transactions, store and manage your assets. And the address generally is almost like your account number that you give to people, so that the public key usually it works too, but public key generally is quite long. Address is generally almost only half the size. Okay, what is test network? I think this is quite intuitive. Is kind of like in the name. it is almost like the main network twins. It have the same consensus protocol. It has the same way to do it. Sometimes the gas fee might not really similar because the actual traffic in the mainnet and the testnet might be different, that causing the calculations of the gas fee, if you want to estimate, like, usually how much gas fee you would need for this kind of application, might not be very accurate. Of course, again, it depends from blockchain to blockchain, and you do not need to buy the coins on the test network. Normally, you will have something called the faucet, which give you free coins to test your applications. So it's the sandbox for you to test your smart contract as many times, as many way, and try to hack it as much as possible before you deploy it to the actual main network. And usually it would have a testnet explorer as well. So what is an explorer? We are going to talk about it next. And what is an oracle? You might need to deal with the oracle, you might not need to deal with an oracle. It depends, like what kind of applications you are building. So this is the blockchain. Probably so this is the blockchain, probably tongue twisted. Okay, this is a blockchain and it's properly architected here. But sometimes you do need some informations outside the blockchain itself. Take for example, if you are building a smart contract that is based on the weather forecast, if it's raining, we are going to execute this smart contract. So I need to know whether today is actually raining. So where are you going to get these informations? You can base it on forecast. So if forecast say today this time is going to rain, so at this time I'm going to execute this smart contract. Or you even can have an IoT that is a device that detect rain. Then when the device detected is raining, it's going to send the informations to the blockchain, and the blockchain is going to execute this smart contract. So this is called the oracle. Things is coming from outside of the blockchain. Of course, there are still some challenges that we face. We talk about blockchain is very good for supply chain, because supply chain is all about tracking something from A until to Z, right? And if you want to keep track of all these things, right, to make sure for example, some organic crops, from how it being grown, being harvested, being packaged, being sent to the retailer and to the customer. Everything here, we want to make sure that like none of the data is being tampered. We want to put it on the blockchain. Fantastic idea, and it's very good idea. But the challenge is always the informations that coming into the blockchain. How correct it is? How true is it? We still kind of like have this kind of challenge here, because not only about the accuracy of the IoT and how in time it is. Don't forget that blockchains needs internet in the process of transporting. Would that be an issue? If that is, even though you have the IoT, you might not get the informations kind of like live. So that, and then also it won't, the problem that we face of garbage in, garbage out is still the same for blockchain. So whatever information coming in, if it's not correct, whatever information output you get is also not correct. Still garbage in, garbage out. However, if the information coming is correct, that would be what we call the oracle, the information that is off chain that fits to this blockchain. So the explorer, what you can do with the explorer? The explorer, you can check the block details, like when is this block is formed, when is the block height, what inside the block, how many transactions, how big is this block, how much of transactions fee is generated, who mined this block, what is the hash for this block. All these things you can find it in the explorer. And for the transactions, you can find who is the sender of this transaction, who is the recipient of the transactions, how many coins is being transferred, is there any messages attached, is there any, is it a NFT that is being transferred, uh, what is the hash for these transactions, and account details. If you see, if you want to check like the history of the transactions of this account, you can check it on the explorer as well, as long as you have the address of this account. And you can check the contract details of a smart contract. You can check that, like, who execute this smart contract, who have used this smart contract, and says, for example, of NFT, how many of this NFT have been generated from this smart contract. All this. And for the mining nodes, you can check that, like, how much reward they get, which block they mine, and the nodes informations as well, like who owns this node. When I say who owns that nodes, might not be the person name, it's just the account informations. So it looks like this. For the Ethereum, it's the most famous one, the common one is Etherscan. It's started by Malaysian. You can see that not only it have the transactions, the hash rate is like, all the computing power, and the medium gas prices, and the difficulty. The difficulty is like how difficult is the puzzle that the nodes need to guess to get the candidate block selected to add to the block. So this is a difficulty. And it also tells you the market cap, how big is the market cap. And to the latest block, you can get the block heights here. Who is the miner? And how many transactions inside? And in how many seconds? In 14 seconds, it have 20 transactions in this block. And the latest transactions, right? And this is for the blockchain.com. The blockchain.com is show you the informations of Bitcoin, but here they also include of other blockchain as well. And for the Etherscan one, actually it also includes NFT and the smart contract information. You just have to navigate. For Explorer, actually is quite a lot of informations, and you really need to take some time to learn what are those informations are for, how it is going to be useful for you. Now, here at the big blockchain.com for Bitcoin, it will show you also what is the latest block, how long ago it is being created, the block height, it means like the block number, which one is the block number, how many transactions. It will also show you the last transactions that is made. And for Algorand, is the Algor Explorer. it will tell you also the latest block, the circulating supply, how many algo is out there, how many is stick online, the total supply, and also the price, the block speed, the how many transactions per second, the latest block, and the latest transactions. And this is for the mainnet. And sometimes, right, you can, for most of the Explorer, you select, there could be a testnet Explorer that look exactly the same, but the data is getting from the testnet, and sometimes there are different, some blockchain might have different net, some blockchain might have different testnet as well. It means that they not only have one testnet, they might have a few. So these are the informations generally you will get from the Explorer. As I mentioned earlier on, the block heights, which is the number of the block, the latest transactions, minus informations, block time or the speed, and the transactions per second, the cost of the transactions, and the gas fee. Of course, each transaction will have different gas fee. You can click on to the transaction to see how much transactions fee it is paid. Okay, up until here, any questions? I do think as the Explorer is kind of a heavy topic too. There's a lot of things goes inside this Explorer. All right, from Tia, how do we know if a smart contract or a blockchain is genuine? Good questions. Let me have some water. First, let's talk about how we're gonna know a blockchain is genuine. Now, one thing I did not touch here is the private chain and public chain and hybrid chain and consortium chain or whatever, because I think at this stage for this program is not what you are going to focus. But let me touch a little bit here. Now, when it's a public chain, anybody can join. Even that you want, you can join as a node. Then you can see how it works, whether it makes sense. Of course, for you to be able to do that, probably you will need to have more knowledge about blockchain, because learning to code a smart contract is still different than coding a blockchain and running a mining nodes, and it is different set of knowledge. Whether it's genuine, I think every blockchain is genuine, whether it's testnet or mainnet. I think what you are trying to say that like whether they are legit or they are going to last long or not, that is very subjective, because whether a blockchain is going to be a common not common one, whether a blockchain is going to be a popular one and a long-lasting one and is a vibrant one, it depends a lot on their community. If the community have built a lot of use case on that blockchain, it's less likely anybody want to tamper this blockchain, because the community first wouldn't want this, and having a healthy community is actually more beneficial and probably have more returns than go and tamper it. And whether a smart contract is genuine or not, check it from the Explorer. If they are deployed on it, it is genuine, it is a real smart contract. But if your question is whether the smart contract is good or not, it takes a lot of experience to find out. And there is some audit for smart contract out there that you can send your smart contract to audit with the fee. Of course, usually only if you're running a project, people will send their smart contract for audit. Tia, I'm not sure if that is what you mean. Just give me yes or no, or if it's not, can you ask the questions again? there's some problem, a real life problem that blockchain can solve. It might not be able to solve all the problem, but some of it. Now, some of the possible solution for some of the problems is listed here. Just want to give you guys some idea, so that probably be, then you can start to go back to think a little bit about it within your group, and probably you can start to think what you want to do for your hackathon. Okay, now we are talking about if you have heard of Web 1, Web 2, and Web 3 is the buzzword nowadays. When we talk about Web 3, we talk about blockchain technology, because generally Web 3 is supported by blockchain, and Web 3, one of the main distinct function is for the user to own their own data and their informations. We're talking about Web 1. If you want to sign up to and sign into any website, you will have to create your own user's name, your password, and each website would have a different one. And we come to Web 2, we do not necessarily have to do that, like one user name and one password for one website. We can use our Google account, our Facebook account as a sign into the website. And that also means that some of this big company like Google, Facebook would store a lot of our informations. Not only that, is also as our store a lot of our behavioral pattern. And that's where they profit from, right? And talking about Web3, we are talking about just sign into any of the application using your wallet. You don't have to disclose your name. You don't have to disclose your personal informations. You are represented by your key pair. And if whoever want to mine your data or mine your behavioral pattern, they probably can buy it from you, because you still keep your own personal data behind that key pair, right? So that is one main issue that blockchain can solve, is to give privacy for the identity and the ownership of the identity as well. So it also almost can be used like a digital ID as well as a membership. Now, as we know, I think it is not something that like you hear for the first time, is there is always more solutions to it. There's always more than one solutions to a problem. So in order for you to have this privacy for your ID, to have a digital ID, you can either use an account, or you can use an NFT to represent a person. So it's just like you buying into a bot app. That bot app is kind of like your membership in this yacht club, right? And you could hold two membership as well if you have two NFT, right? So that is how blockchain used to create a digital identity or a membership. And if you use an NFT as a membership, it makes your transfer of the membership easier as well. So if you want to use it as a digital identity, generally, I would suggest using an account, because ID is ID. You're not going to transfer ID to somebody. I'm not going to transfer my name, Ivy Fong, to you. That's my identity. But I can transfer my membership of my yacht club to you. So in that case, NFT would be more suitable. You can use blockchain as an authentication, as informations on the blockchain cannot be mutable, right? So if you want to make something permanent, put it on the blockchain. You can use it as a metadata or sign a transactions with some informations attached as a metadata with your private key, and that means like you own that piece of data. Of course, there's a lot more sophisticated programming or structure that you need to get done behind it, but the general idea is sign the transactions with your private key at almost as good as you paint a painting and sign your signatures on it. Tokenizations, whether you tokenize the money or you tokenize a one-of-a-kind asset. We have talked a lot when we are talking about fungible tokens and non-fungible tokens. And you can even use NFT or even fungible tokens, depends on your use case, for fractionalized ownership. For example, if owning a house is such a burden and it's not achievable for people just start working, probably we would like to fractionalize it, the ownership, by using fungible tokens or non-fungible tokens. So each person can buy into maybe 1% of the property, 2%, 10% of the property. Again, I have to mention that legal issue could be something that like we need to think about for this issue, but who knows, we may find some other ways of like settle this issue, or the rules and regulations come in place, right? Do not need to limit yourself too much when you're thinking about like what project you want to do for your hackathon, but just all these informations I mentioned here is just so that you know, right? Now, for tracking of things, just like I mentioned just now, is the supply chain on blockchain. Supply chain is the best use case for blockchain. There could be some challenges, but then all we need is for every single step, we lock the details in the transaction, sign it off, keep it in the blockchain. Everybody can check, make it transparent, and there is where you create trust in your consumer. Atomic swap is like what I mentioned earlier on. For the escrow, it doesn't have to worry about who pay first. A and B have a deal, who have to do the transaction first, and that also include that if I want to swap my coin with two different blockchain as well. So these are some of the real life problem that we want to solve and how you can solve it in using the blockchain. This project, Bored Ape Yacht Club, it is not only selling the pictures of the app. It has a lot. If you look into its white paper or the recent presentations they have for their roadmap, it is, you buying into this NFT is like getting into the community. It's all about community building. Is when you're in this community, you probably will have some privilege. Now, even if you buy into a certain NFT and there is a promise saying that like if you with this NFT you're gonna get this and get that, whether that's going to be delivered, a lot of the time it depends on the people behind it that running it. Because for example, if they say that like if you buy this Bored Ape NFT, you'll be able to come to so and so concert with a discounted price. The blockchain is not going to execute for you. The blockchain is not going to organize the concert. It is the people behind it that's going to do it. And this NFT is only going to act like a VIP access for you. It's just like, you buy into any membership. The execution is still very important. Now, even if you buy into an NFT and it doesn't have anything, but probably you buy into an NFT for a piece of art, and this piece of art is delivered to you, I think that is good enough, right? you buy the NFT, proof that you own this art, and that art physically is actually delivered to you. But what if one day, right, there's artists who have a lot of art sold and have an NFT representing the art, saying that like, whoever own my NFT, now I am going to throw a party, and with the NFT you can come to my party for free. So that is something extra that you come. It's just like when you own an NFT, once in a while people is going to have some special promotions for the members. So this is one way of how you use NFT. And what is the benefits of having an NFT as a membership? Then we have been doing this NFT membership for a long time, right? It's not the first time that like we have this idea of doing an membership. What's so special of using NFT? Now, using NFT, it makes the transfer of the membership easier, and there could be a increase of the value if a lot of people want this membership. Think about it, it's like a golf club membership. If you want, you can sell your membership, usually would have a fixed price, that the market price that the golf club would have. And if you want to transfer the membership, you need to go through them. Of course, if you don't want to sell it and somebody willing to pay extra for it, you can. But with the NFT, right, you can put it into the market and then let everybody know that like you are willing to part with this NFT, willing to part with this membership into this elite club, and this is the price, or you can even let people bid for the price. And you do not need to disclose, again, you don't have to disclose your personal information. Like if you go through the golf club would have all your personal details. With this, you do not need to. And what best out of it is, sometimes for two companies, they might want to have collaborations for their membership. And sometimes they do not want to disclose their members to the other company or another organizations. So that makes these collaborations a bit difficult. But if you use this NFT as a membership and the identity is anonymous, that take away the worry of the company that okay, I'm disclosing my customer informations to you, the other way around. So that could create more collaborations opportunities between organizations. Now this is another project that I recently come across and I do like it. It's called Is the Ship. It is a cruise that is run in Malaysia, Singapore, where they recently have drop of this duck. The yellow. The NFT is not necessarily a yellow duck, but it's the concept coming from like the yellow rubber duck. So if you're the holder of this NFT, you would have special, and probably you might be guaranteed. Okay, I'm just making it up. I do not remember their terms and conditions, but I'm just making it up. Roughly is, so if you go and buy the NFT, don't come and say that like, because Ivy said that like if you get this NFT, you're going to get guarantee a cabin in this ship. No, I'm just making it up. So probably if you have this NFT, when they have party on the ship, you're going to get the entrance to it, and probably you're going to get a free nights at their cabin, or if they have any inland party, you're going to be invited to it. So this is something that you can do with the NFT as well. And then we talk about this swap between the blockchain. So there is a lot of others like swaps, Uniswap, PancakeSwap, and SushiSwap. I think that probably you guys have heard of it as well. Sushi swap is not for you to swap your sushi, yeah? Or pancake swap is not for you to swap your pancake. So they allowed you to do this swapping between coins from different blockchain as well, and that's what I called it earlier. Not I called it. That is what it being called, the wrapping the coins. And what is the difference of this? You swapping your coins here than using the exchanges. The exchanges, for example, like Binance or B or even Uno, there is exchanges that even though they are online, they're just like the e-exchanger. They are still the middleman to take your Bitcoin and give you Ethereum if that is what you want, right? Uniswap, PancakeSwap, and all kind of swap like this, right? They generally execute using a smart contract. Now each have their own way of doing it, even though they're called the swap. But again, just like the NFT marketplace, their smart contract can be different. Okay, I I think I come to the end of the presentations. Um, what I can say is I really like what this person said is to master a new technology, you have to play with it, by Jordan Peterson. Blockchain is nothing near perfect yet. It's still building it. And it's a good time for us to jump in and play with it, even though that is not perfect. Because that is how the technology improve. If we can see that right now how the technology is improving, it change very fast. There is almost hardly any time we can perfect the technology. So don't worry too much, like Ivy said this is have this issue. Should we try it this way? Just try it. Mana tahu you are the person who find out the solutions, right? Okay. That is what I want to present. Do you have any more questions? Generally, this is the um, common things that you need to know before you get into uh, learning the smart contract. There's a lot more need to be covered, of course, but I don't think we should have talked about more subject as well, because that would be a lot to take in, right? When we start the hackathon, in October, so start on 5th of September, you will every Monday, you will need to tune in 9 p.m. our time. The link will send to you later. So make sure that like your email is correct. On the 5th of September, you will be shown how to create your wallet, and you need to will let you know how is the rules and regulations for the hackathon, and what you're going to get if you finish the course, and how is the bounty be like for the hackathon, and all these things. And the hackathons will actually start in October after the class is over. So the class will be 4 weeks, 4 Mondays, 9 p.m. to 10:30. Estimate. Uh, we can't exactly know how long it's going to take, but roughly it's going to be there, because it also depends on how many questions you have and all these things. So yeah, generally that is how it is. And then for the hackathon, starting on October, you will have about a whole month to work on it. During the period of time, October, every Monday 9:30, you still need to tune in, because that's where we're going to look at the code. We are going to give you tips on the hackathon, and yeah, maybe some about like how to pitch on your hackathon and the rest. Feel like a lot to learn. Yes, Narendran, it a lot. This is only a small part of it, and this is specially tailored for you all for the coming courses. A lot of the things will not be covered if it's only a blockchain 101 for general. In general, like I won't go into so much into the smart contract. I won't go in so much about like how the blockchain works, and I won't go in about like how the architecture of the blockchain. You don't necessarily know even the architecture of the blockchain when you're doing smart contract. You kind of need to know it, but you don't exactly need to know so details of it. But it's good to know because it can grow your interest. Maybe you want to to study further. So yeah, why not? That's what I'm thinking. Yeah, there's a lot more to learn. And if you want to know more, you really interested to know about blockchain, then you will need to know about cryptography. Yeah, you will need to learn more about database. And if you are interested to know about how to build a good project, you probably need to learn more about tokenomics, which is a lot more towards economy.